Yes, dear students, now I am solving some questions which have been asked in competitive exam regarding isothermal and adiabatic processes. So there is single question here: monoatomic gas at pressure P. Monoatomic gas at pressure P is compressed first isothermally. Is compressed isothermally sorry, not is sorry, monoatomic gas at pressure P expands isothermally to isothermal gas at pressure P and volume V. Expand isothermally to volume 2V and then adiabatically to volume 16V. What is final pressure? What is final pressure? हाँ भाई, final pressure. Options are here. First option 64P. B option P upon 64. C 32P. D 16P. So you have to choose the correct answer. So monoatomic gas at pressure P, volume V, expand first isothermally to volume 2V and then adiabatically to volume 16V. So what is the final pressure? Isothermal process. During isothermal process, P2V2 equal to P1V1 और P2 equal to P1 P दिया हुआ है V1V और ये 2V, तो प्रेशर P2 become P2 P by 2. Now gas expands adiabatically. So that way P1 V1 to the power gamma equal to P2 V to the power gamma. Here gamma given है 5 by 3. Monoatomic है तो we must remember it is 5 by 3 also. So P2 equal to P1 into V1 upon V2 to the power gamma. P2 here now is P2 by P by 3, P by 2. V1 2V, V2 16, 5 by 3. 16V, sorry. V cancel. P by 2 into 1 by 8. to the power 5 by 3 means 1 plus 2 by 3. It means P upon 2 into 1 by 8 or into 1 by 8 to the power 2 by 3. One upon 8, 1 by 3 square will become 4. So 4 8 so it is P by 2 into 1 by 8 into 1 by 4. So it is P upon 64. So this option is correct. So please try to follow me what I say. This question has been asked in NEET PMT, All India PMT 2014. All India PMT CBSE used to conduct this exam. So this is a question here. Now there is another question. A given sample of ideal gas occupies volume V at pressure P. Pressure P, volume V, given mass. Pressure P, volume V. अरे यार चले जाओ. अरे भाई इतना शोर न मचाओ यार. शोर न मचाओ इतना भाई, चुपचाप यहाँ काम नहीं कर रहा भाई. इनसे इसमें फोन है बड़ी में काम कर रहे बेटा. तो given mass of gas is at pressure P and has volume V and temperature T. The mass of each molecule is small m. Mass of each molecule. Then density of gas. Which of the following gives the density of gas? Number 1, A बराबर mkt, B बराबर है P अपॉन kt and C इक्वल है आपका Pm अपॉन kt and then D is small k है ये. Small k means Boltzmann constant, you will learn. And P upon KPV like this. KTV. So these are the options. Question is good. क्या कहता है? A gas is at pressure P, given mass of gas is at pressure P, volume V, temperature. Each molecule has mass m. Density. You know density is equal to mass upon volume. Density जो है वो mass upon volume होता है. From ideal gas equation we know PV equal to nRT. Any number of moles. If X be the given mass, then N will be X upon capital M. So PV X upon capital M into RT. Capital M is mass of capital molecular mass. 1 gram molecular mass has NL number. So this capital M is equal to N into small m. 1 gram molecular mass of every gas has Avogadro number n molecules. Number of molecules. अरे बिगड़ जा चुपचाप यार. Volume upon mass, given mass, X is the given mass, is equal to RT upon N into M. R by N, in fact, R by N is K, Boltzmann constant है, Boltzmann constant. So we can write P upon D, mass upon volume density, is equal to K P upon small m. So density of gas D equal to Pm upon Kp. So which answer is correct? C. These are some good questions. Simply you have to rotate your brain. है ना, PV equal to RT. This was there. I hope you have got my point. Actually, जो K Boltzmann constant है R by capital N. N is the Avogadro number. And I have explained many times what is gram molecular mass. 1 gram molecular mass like CO2 gas, that is 44, and that has 44 gram has this much number. But here you are given that mass of each molecule is small m. तो mass of 1 mole क्या होगा? m into n. तो जो हमारा PV इक्वल टू nRT होता है, n यहाँ नंबर ऑफ मोल है, वो गिवन मास हमने x लिया अपॉन मोलिकुलर मास होता है. मोलिकुलर मास होगा हमारा ये मास ऑफ 1 मोल ऑफ गैस मीन्स मास ऑफ n मोलिक्यूल ऑफ गैस, और ये हमारा होगा m into n RT, R by n की हो गया. तो उससे ये दिमाग को घुमाने वाली बातें हैं और कुछ नहीं है. यू हैव टू सिट साइलेंटली इफ यू आर प्रिपेयरिंग फॉर योर कॉम्पिटिटिव एग्जाम. नाउ देयर इज अगेन दिस क्वेश्चन वाज आस्क्ड इन 2016, नीट 2016 क्वेश्चन है ये. Now here is question for ideal gas at constant temperature. The correct graph showing actually 1 term beta equal to minus dV upon dP divided by 1 by E. This is called beta, showing variation of volume, change in volume upon pressure अगेंस्ट प्रेशर P. यहाँ कई ग्राफ हैं. एक ग्राफ है ये लाइक दिस बिटवीन बीटा एंड P. अदर ग्राफ इज देयर लाइक दिस P and बीटा and P, and there is another graph like P and beta like this, and fourth one is P and beta, sorry, beta and P, beta and P, beta here. Other graph is like this. So which graph is correct for this? Actually we know PV equal to constant for ideal gas at constant temperature. If constant temperature, Boyle's law obeyed P equal to K. Differentiating it P into delta V upon delta P. plus V into delta P, P delta V plus V delta P equal to 0. This is called difference, partial differential. और P delta V equal to minus V delta P, और डेल्टा V अपॉन डेल्टा P अपॉन V minus that equal to 1 upon P, and this is beta. You are given this is beta there. So whole thing is beta, sorry. So beta proportional to 1 upon P means if P increases, beta decreases. So this graph is true for this. Am I clear? Now there is another good question here, and this question was asked JEE 2002. Yes, 2002. तो आपको बहुत कुछ सीखना होता है बच्चों. You have to learn a lot. Only then you can succeed, and for that you have to sit in your room for a number of hours continuously without break. Now there is a question here. 5.6 liter. 5.6 liter of helium gas, of helium at STP. STP is adiabatically compressed. Is adiabatically compressed to 0.7 liter of its volume. Taking the initial temperature T1, actually STP को T1 मान लिया इसने. Initial temperature T1, initial temp T1. The work done by in this process, ऑप्शन दिए हुए हैं. A बराबर 9/8 RT1, और बी ऑप्शन है 3/2 RT1, 3/2 RT1, और सी ऑप्शन है 15/8 RT1, and D option is there 9/2 RT1. तो यार 5.6 लीटर वॉल्यूम एट STP. Actually initial temperature gas initially at STP. STP means 273 Kelvin and 1 atm pressure. Temperature T1 इसको लिया है इसने. And there is one fundamental law of gases at STP. At STP 22.4 liter is the volume occupied by 1 mole of gas. तो 5.6 liter which has how many moles? So 5.6 liter at STP equal to 5.6 upon 24 moles, यानी कि 1/4 मोल. तो पहले तो हमें थोड़ा सा वहाँ जाना पड़ेगा. Student who are preparing for conde exam, they know this thing well. Actually, class students have not learned gas equation, gas law properly. But you remember, 22.4 liter at the step is equal to 1 mole. So this is how much mole. Now, T1 V1 to the power gamma minus 1 equal to T2 V to the power gamma minus 1. So T2 is equal to T1 into V1 upon V2 to the power gamma minus 1. It is helium gas. For helium gas, gamma is equal to 5/3. ये हमें याद रखना होगा. और T1 हमारा T1 ही है, V1 5.6 upon this 5.6 upon 0.7, 5/3 minus 1. So it is 8. T1 into 8 to the power how much? 2/3. Again it is how much? 4. So 4 T1 is this temperature. T2 is this. Now W is equal to nR upon gamma minus 1 into T1 minus T2. So you are asked only magnitude. N is 1/4 into R. 5/3 minus 1, 2/3. और इंटू T1 है T1 minus 4T1. तो it comes out to be 3. तो 9/8 RT1. वर्क डन, ये माइनस का आएगा. माइनस मीन्स वर्क इज डन on the gas. In compressing we have to do work. That's all. In next video I may solve more questions for you. Thank you.